So this is what no one actually saw coming, just when nearly everyone assumed that 3I Atlas was done for. Torn apart by its close encounter with the Sun, the latest images have flipped the entire story. The interstellar visitor isn't breaking apart. In fact, it may be even more stable than we imagined. October 29th marked 3I Atlas's historic perihelion, its closest paths around the Sun. In the days that followed, a storm of speculation flooded the internet and scientific circles. Many believed the comet had split. Photos showed odd dust patterns. Jets looked erratic. Some even claimed the nucleus was cracking apart. But now, that theory is falling apart because the comet isn't. For weeks, the dominant narrative painted a grim picture. A fragile interstellar object, born far outside our solar system, had likely succumbed to solar heat. This was the expectation. After all, we've seen it before. Comets are notoriously unstable, and 3I Atlas had just passed through intense solar radiation. Some early images showed a warped, asymmetric coma. Dust jets appeared to curl oddly, and people began whispering, did it shatter? Was the nucleus breaking into fragments? Was this the end? Astronomers speculated the same. After all, breakups often start quietly, through subtle fractures and lopsided activity. Especially in interstellar comets, which may carry different volatile compounds, heating can behave unpredictably. For many, the strange post-perihelion visuals sealed the theory. 3I Atlas was no longer whole. But then came today's bombshell. A new set of images just released from NEOAT and NEOSAT has turned the conversation around entirely. Using ideal viewing conditions, minimal background interference, and high-contrast imaging, the team captured one of the clearest views of 3I Atlas to date. And there came something we haven't seen before, a brightness contour map, essentially a topographic profile, but for light. Now, imagine a map of a mountain range, except instead of measuring elevation, it shows how bright different parts of the comet's coma are. The brightest areas form tight, circular rings, each one representing a shell of intensity around the central core. If 3I Atlas had split into pieces, the contour map would reveal it immediately. You'd see multiple brightness peaks, lumpy off-center, or distorted regions. But that's not what we got. What we have is symmetry, a perfect circular center, clean gradients outward, no signs of multiple fragments, no stretching, no warping. The heart of this interstellar comet remains intact. This isn't just a visual impression, it's scientific confirmation. A fragmented nucleus simply cannot create such a symmetrical intensity field. The brightness rings would be uneven, broken, or doubled. But here, the contour map proves there's only one source at the center, one nucleus, one object. And that's not the only evidence stacking up. Just hours after the NEOAT release, a new amateur image arrived from an observer in Puerto Rico. Using an 8-inch telescope and narrowband filters, they captured a faint, twisting tail, almost like a spiral curling away from the comet's body. At first glance, it looks like a dust anomaly. But under analysis, it makes perfect sense. The nucleus is spinning, and that rotation, currently estimated at around once every 16 hours, is causing the dust to be ejected in a spiral pattern. It's not chaos. It's physics. Dust jets aren't flowing randomly. They're flowing along curves shaped by a spinning, solid body, a body that is very much intact. Yes, it's an amateur image. No, it doesn't have the precision of professional telescopes, but the shape aligns perfectly with rotational models. Once again, the data doesn't point to a dying comet. It points to a dynamic, evolving, single-nucleus comet. Those claiming the jets indicated fragmentation. This new information recontextualizes it. Unusual jets don't mean a broken comet. They could mean uneven heating, rotational pole shifts, or compositional variation. And now, with a contour plot and rotational pattern to back it up, the narrative changes entirely. The science teams have taken notice. Astronomers from multiple observatories, Drew Doss's team at NEOSAT, Jijialu at Starmount, Lou from the Virtual Deep Sky Group, all agree there are no signs of fragmentation. Not one. The brightness profile, the tail curvature, the coma symmetry, they all say the same thing. The comet is still whole. But the most exciting part may still be ahead. NASA is expected to release high-resolution imagery from the HiRISE camera array any day now. possibly within 24 to 48 hours. And HiRISE isn't just any telescope. It's powerful enough to spot surface details, jets, or even hairline cracks. If there's anything at all unusual happening on the nucleus, no matter how subtle, HiRISE will see it. If these new images confirm what we now suspect, that 3 Iatus has not fractured, it will be a major moment for cometary science. One of the most unusual comets ever seen, with strange chemistry, a backward tail, and nickel-rich emissions, has survived solar encounter fully intact. That's a story we didn't expect to tell. So here we are. The interstellar visitor that sparked so much debate has proven the doubters wrong. Not shattered, not disintegrating, not a fading trail of cosmic dust, but a defiant whole nucleus racing back toward the outer solar system, leaving behind new questions and rewriting what we thought we knew. We'll update you as soon as new information drops in, so make sure to stay subscribed, stay curious, and keep your eyes on the stars.